Okay, we're going to talk about ion concentration. And it's best just to do a sample question here using multiple examples. So what is the concentration of 2.0 molar of each of the following compounds? Okay, and it's really just best to name the compounds and just know each of these compounds, these are binary ionic compounds. So they're made up of two ions. So sodium and chloride. Okay, sodium is Na plus, and so that's one of its ions. And then chloride is Cl minus. So when these two are in a beaker together, you have NaCl, and then if it's soluble, they'll break apart. And then you'll have an Na plus floating around and a Cl minus floating around. So the way you do this is you just take the molarity they're talking about and you multiply it by however many ions are floating around in there, okay? So 2 times I have 1 Cl, so your molarity for Cl minus would be 2.0 molar. Okay, and then here you have Na, you only have 1, so it would be also be 1 times 2.0, 2.0 molar. Okay, let's look at these next ones here. Calcium fluoride. Okay, calcium is Ca, 2 plus, and fluoride is F minus. Okay, now when I form this compound, when I do the switcheroo and I round together, you have CaF2. So if these were going to dissolve in solution, you'd have Ca2 plus, and you'd have 2F minuses floating around. Okay, so you take 2.0 times 1 is 2.0. 2.0 times 2, you have 4.0. So when ionically, when it splits off into its pieces, there's a higher concentration of F minus, double in fact of Ca plus, because there's twice as many of them in the solution. Okay, let's do the last one here. Ammonium phosphate. Ammonium. And then phosphates. So when I put them together, NH4, PO4. Okay, and I have, I'm doing the switch, I switch the charges, so +1, 3. Okay, and so let's do the easier one first. There's only one PO4. 2 times 1 is 2.0 molar. Okay, 2.0 times 3, you get 6.0 molar. And that is how you do the concentration of ions specifically.